Question 7. So we've been asked to show that this equals this. So starting off from this, well, we really can see that we're going to end up having to have a single term, so we really need to make this become a single term. So in order to do that, we're going to need a common denominator. Now our common denominator is going to have to include each of these factors, each of these brackets. So 2x plus 1, an x minus 3, and an x plus 3. So this first term we just choose to multiply top and bottom by x plus 3, and our second term we choose to multiply top and bottom by 2x plus 1. We now have a common denominator of this bottom triple bracket. So we just we do FOIL on here, so we multiply out this pair of brackets when we multiply out this, and that gives us this as a numerator, and of course all of this is now over this single common denominator. The 4x squareds cancel, tidy up the x's, giving us 5x minus 15 over this common denominator. We can then factorize the numerator, giving us 5x times x minus 3, and now the x minus 3 factor cancels from top and bottom, leaving us with 5 over 2x plus 1, x plus 3 as required. Now for part B, we're being asked to find an equation of the normal to C at P. Now, the equation of the normal, that's just going to be the C1 formula, y minus y1 equals mx minus x1. We obviously know a point on the line. We've got this point here, so there's our x1, y1 sorted. All we need to do is know the gradient of the normal. So to do that, we're going to have to work out the gradient of the tangent. So to do that, we're going to have to differentiate y. So we need to find f dash x. So we're going to have to differentiate our function. So we use the quotient rule. So u is 5, v is 2x squared plus 7x plus 3, du dx is therefore 0, dv dx is 4x plus 7. Substituting it into the formula v du dx minus u dv dx all over v squared, we get this. Obviously this is being multiplied by 0, so that term goes. So our numerator comprises minus 5 times 4x plus 7, and that is our denominator. Now we're trying to find the gradient where x equals minus 1. So we substitute minus 1 into this, giving us minus 15 over 4. Now that is the gradient of the tangent. We need the gradient of the normal. So we flip this over and change the sign. So that is our gradient. That's how we got the gradient. So substituting it into our C1 formula, which is this. There's our x1, there's our y1, there's our gradient. Minusing a minus is a plus, so we end up with that as our final answer. No need to take it any further than that, because they did not require us to have our equation of the normal in any particular format, so that's fine. Don't waste your time multiplying out and making it y equals or whatever. That's your final answer.